In this problem, we are going to look at problem first, analyze it, then what type of tests we are going to go for. Marketing manager of a cell phone company is working on an ad plan that is to be directed toward a young audience. In conjunction with the plan, the manager states that the average age of the company's customers is younger than 40. So this is something that he kind of claimed. For actually completing the advertising plan, the manager decided to randomly sample customers. Among the questions he asked, or in a survey of 50 customers, was the customers' ages. Examine the sampling or the sample data. Is the variable being measured a discrete or a continuous variable? Does it seem to be feasible that these data could have come from a normal distribution? The marketing manager must support this statement concerning the customer age in an upcoming board meeting using significance level of 0.1, provide support for the marketing manager. So first of all, we have to think about what is the sample. The sample, we have only one group. So we're talking about one sample only, 50 randomly sampled customers. And we would like to compare their average to a single known value, which is 40. So we don't have any second group. So first of all, we have one sample. So this is important solution. We have only one sample of 50 randomly sampled customers. Okay. Number two, variable of study is the age, which is continuous. Someone's going to tell me, okay, people normally report their age as a whole number, so it's discrete. It's dealt as discrete, but it's a continuous by design. It's continuous by default. By itself, it's a continuous, okay? And we treat it for statistical reasons and purposes. We treat this as a continuous variable. It's a quantitative continuous, okay? What we are trying to find, we are the marketing manager. The marketing manager claims that the customers are younger than 40 on average. We want to test this. Do we support that? Is it true or no? We're going to test this. Marketing, okay? So basically, our null hypothesis is going to be, what is going to be the average, the population average. Actually, it's not younger than 40. It's equal 40. The status quo is 40, or equal or greater than the opposite of his claim. It's equal. So the average customer age is 40 years old. The alternative hypothesis, which is his claim that mu, the population, someone's going to tell me why we are studying the population. Yes, because we are studying the population. We took sample and we would like to draw conclusion using this sample about the population because we care about the population. We don't care about the sample. We would like to learn about the population from the sample, okay? So the average customer age is less than 40. So this is a one-tailed test because the alternative hypothesis give you one side only. It's a one-sided test. So this is a one-tailed test. Alpha is 0.1. Now the question is, this is a one-sided test or one-tailed test. It's a left-tail test. One-tailed test. It's actually left-tail test. So it's a one sample, left-tailed. We have no clue about the population, so-called standard deviation. Then we think about one sample t-test. However, before we decide going for the one sample t-test, we have to do the normality test. Check normality first. Okay, we want to check the normality. How to check the normality? Using three tools. The normality tests, I'm going to go for Shapiro-Wilk. Second, we look at the histogram. And third, we look at the QQ plot. Then we make a decision about using the one sample t-test or no. The question is, if the normality passes, then we do the one sample test as we did in the previous example. But if this did not pass, we're going to go for something called Wilcoxon signed rank test. Wilcoxon signed rank test, single population. When do we use this test? We use this one if the t-test is not appropriate. Let me write this. If the one sample t-test was not appropriate, we go for Wilcoxon signed rank test. Someone's gonna tell me, okay, when do the t-tests not work? I mean, when the t-test is not appropriate. The t-test is not appropriate if test is not one sample. I'm talking about one sample. T-test is not appropriate if the data level is ordinal or the populations are not believed that it's not believed to be approximately normally distributed. Okay? So that's why what we're going to do, we are going to look at now, we're going to go to SAS. My data is already there. If you just watch the one sample t-test to know about how did I uploaded my data and send them to the library. I have them already, so I don't want to repeat this. So I'm going to go there. I'm going to select the so it's a one sample test. I care about the age only. Then I'm going to go to options. Really, what I'm going to do, it's a one tail test, but I'm going to keep it two tail test now, because if I change it to one tail test, it's not gonna show me the Wilcoxon signed rank test. So how to deal with this, I'm going to show you. But I'm going to keep it two tail test. I'm going to choose this as well. And the alternative hypothesis, it's not the mu is not equal to 40. Is not equal to 40. This is the alternative hypothesis. Then I'm going to keep the default plots. One more thing I'm going to change, which is the significance level. If the significance level is 0.05, you can just run from here, then you're done. If you want to change it, do edit to the code. Then where is the t-test? There's the t-test, right? Then I'm going to add alpha equals 0.1. Also, I'm going to add alpha here for the non-parametric test, alpha 0.1. That's for the normality. I'm going to add alpha 0.1. Okay. Then I'm going to run. Okay. Again, we first need to look at the normality of the population. And we can use either Shapiro-Wilk or Anderson-Darling or others, but I said I'm going to stick to Shapiro now. And Shapiro, and what are, by the way, if you look at what is check normality, let me write this. Check normality. Number one, hypotheses are. Hypotheses of the normality. Let me copy them from the previous example. Hypotheses. These are the normality test hypotheses, but I want to change a few words. Population of the age follows a normal distribution. The population of the age does not follow a normal distribution. These are the normality hypotheses, okay? These are the normality hypotheses. Oh, if you look at Shapiro-Wilk, Shapiro-Wilk says the p-value is 0.03. So Shapiro, I'm going to say this at the end, Shapiro-Wilk, the p-value is actually equal 0.003, which is less than 0.1, my alpha. What does this mean? We reject the null hypothesis. When you reject the null hypothesis, what does this mean? It means that the age does not follow a normal distribution. We cannot assume actually the population of the age comes from a normally distributed. So it did not pass actually the normality test. And what is the other test we're going to look at? Actually, if you look at all of them, all of these tests give you the same thing. Reject normality. We're rejecting the normality. And what if you look at the sample distribution, We do have evidence also to do that because the sample, it seems that skewed to the right. Look at the box plot. The box plot, this is kind of longer. And this is, look at this mean. This is the median. This guy is longer than this one. So look at the histogram. The kernel, it's skewed to the right compared to the blue one. Skewed to the right. We have some bumps here as well. So also the box plot, the QQ plot, we have deviations not just from both tails. This is not very close to the diagonal. I mean, all of them tell the same story. The histogram, we have the red kernel curve and the blue normal curve. They diverge. They are not very close. And as you said, it's a clear deviation for the QQ plot. The upper tail, as you see, deviate above the diagonal, and the lower tail above the diagonal. So we have skewness here. So the normality test tells you that, hey, we cannot actually t-test. We cannot use the t-test. So we have evidence, strong evidence, and consistent actually, to say that, hey, our data do not follow normal distribution. So that means we're going to go for Wilcoxon signed rank test. Then now we can read the table. This is the sample data. We have 50. The mean of the age is 38.5. The standard deviation 12 years. The minimum age was 19. The maximum age was 74. Look at how we have some. Look, the outlier, 74. Look at the outlier. The outlier sometimes change the whole story. We will not read the t-test table because we said, oh, this is not going to work, so we will not be reading this. It's not going to give a reliable answer. So what we do, we're going to use the Wilcoxon signed rank test. And remember, Wilcoxon test is used to test hypotheses about the population median. So I go back, actually, and I change this to median. Population median. We can say, I forgot, tilde, no. Let me use box. Actually, population median, okay? I'm going to look at the mathematical polls later. Population median. So Wilcoxon tests use a population median. Why is the median? Okay, the median is the midpoint in a population. So allowing for sampling error, we expect approximately what we accept. We expect approximately half of the data values in any random sample to be below the hypothesized mean and about half to be above it. So we are expecting that half of the sample, which is 25 in this case, to be above the 40 years old and half of them below that. And we reject the hypothesized median if the actual data distribution shows too large or departure from the expectation. So this is the Wilcoxon signed rank do. So which one we're going to look at? The first one is the t-test, is the typical t-test we had, is this one actually. And we will not look at this one. We can look at the signed rank and we can look at the sign and or the signed rank. This is the more powerful one, which is the signed rank one. The statistics is negative 150. It's negative 150. And the p-value is greater than 0.1. right? What does it mean by the statistics value is negative 150.5 means that the customer below 40 are also further from the 40 in a distance. So actually it's far away because we are ranking the data. It's a very simple concept, by the way. I'm not gonna here to explain it. It's a very simple concept. You rank your data above 40, below 40, then you give them ranks, then you find the summation of the ranks, then you see. So look at how far we are. It's below the 40. And if you look at this, the p-value is less than, oh, I forgot to say something. Someone's going to tell me this is actually greater than 0.1. No, we have to divide this by 2 because it's a one-tailed test. This gives us the two-tailed test. So what I'm going to do, I'm going to divide this by 2. So divide the given. I don't want to type this, just divide this. So this is going to be 0.114 divided by 2. This is going to be approximately 0.74 or 5. 0 here. Yep. And this is the p-value. This is the p-value. Okay, this is our p-value because it's a one-tail test. The table gives us two-tail test because we have chosen two-tail test. And this value is less than 0.1. This is less than 0.1. What we do, what is the decision? So the conclusion is, and by the way, because it's less than 0.1, which is alpha, that means we reject the null hypothesis. We reject this fact. We reject that the population median is equal to 40 or equal or greater than 40. The population median is actually way less than 40. It's way less than 40. But how to write this as a APA style or whatever? We do a one sample signed rank test was conducted to determine whether the median of customers was less than 40. Someone's going to tell me, okay, what about the mean? Why didn't we find the mean? Because the idea is we are studying the central tendency measure. Sometimes we use the mean, sometimes we use the median, the one that works, or the one that actually our assumptions takes us to. I mean, if we are in a position to use the mean, then we use the mean. This test used the median, by the way. That's why 40 years old, right? So normality, we can say that normality was violated based on Shapiro-Wilk. W was, where is Shapiro-Wilk? 0.9. Shapiro-Wilk statistics value takes values from 0 to 1. 0 to 1 is going to be normally distributed. Closer to 0 is going to be no. The p-value 0.003. And the Wilcoxon signed rank indicated that in customer age, we can write the median here to 5.5. Deviation was 12.997, was significantly less than 40. And we do have the statistics negative 150.5. Also, we have p-value 0.0, not negative, 0.074, we said, right? Because we divide this by 2, the p-value. The alpha should be written in alpha equals 0.10 significance level. There is sufficient evidence to support the marketing manager's claim that the average age of customers is younger than 40. So maybe this is the conclusion, and it's enough actually. This is everything about one sample. Wilcoxon signed rank test. There is one more thing that I would like to say about the outlier, which is very important. If you look at this outlier, it's actually to the right. That's why it pulls the mean to the right. Look at the median and the mean. The mean is pulled to the right because of this outlier. And the question is, do we need to kind of remove it, consider it, do the test without it? If you actually take this off, it's not going to change your conclusion because the mean is going to go to the left. Probably normality test is going to be fine, and we're going to end up using the t-test. But I don't think it's going to change our conclusion about the mean. The managers claim that the average age is less than 40. It is because everything's going to be shifted to the left, actually. But the idea that I would like to say here is we need to look at the outliers. And if this outlier was to the left, so probably we want to consider remove it and conduct the test without it and see. So sometimes we have the significance, the statistical significance. Sometimes we have to interfere and look at the logical consequence of removing or considering the outlier.